Greetings. Today we'll be introducing the topic of computer vision, a field which includes methods for acquiring, processing, analyzing, and understanding images and videos in order to produce meaningful and symbolic information about the world. My name is Andrew Payne, and I'm an architect and doctoral candidate at Harvard's Graduate School of Design. My research focuses on embedded computation, parametric design, and new fabrication technologies. I'm also a co-author with Jason Kelly Johnson of Firefly, an add-on to the Grasshopper plugin which bridges the gap between the digital and parametric worlds of Grasshopper and the physical computation side of sensors, actuators, and the Arduino microcontroller. Firefly also features a suite of computer vision tools, many of which we'll be covering today. Now this course is going to look at capturing devices, primarily cameras, and how the data that they collect can be analyzed for various patterns. We'll look at the fundamental structure of how data is stored, the algorithms used to analyze this data, and how they can be employed in real-world situations. At the end of this course, you'll have a better understanding of camera optics and how image data is captured and stored. In addition, we'll look at filtering techniques like blurring, embossing, and even creating your own custom filters via convolution kernels. We'll look at how local changes in brightness can determine sharp edges in an image, and how these discrete derivatives can indicate specific information like the direction of steepest ascent in an image. We'll also look at how these same processes can be applied to sequences of images, like videos, to analyze things like the direction and magnitude of movement, the centroid of specific colors in an image, averaging information, among others. Now before we get started, it's probably best to provide a concise definition of what computer vision actually is. Computer vision is a field which includes methods for acquiring, processing, analyzing, and understanding images in order to produce numeric or symbolic information about the real world. Because you're watching this video, you likely already have some interest in computer vision, but you may be wondering why it's important. Well, for starters, computer vision systems have become cheap enough that they are being embedded into all aspects of our lives. There are computer vision systems which inspect products as they speed by on production lines for increased accuracy and efficiency. There is actually a massive amount of energy focused on artificial intelligence research and developing computers or robots that can comprehend the world around them using computer vision systems. Google's self-driving car, for example, uses a host of sensors, global positioning systems, and a laser radar system called LiDAR to autonomously navigate real-world urban conditions. Visual servoing, also known as visual-based robot control, is a technique which uses feedback information extracted from a vision sensor to control the motion of a robot. Here, the ARMR3 robot uses an image data to plan movement trajectories and interact with the world around it. Machine vision systems like the Microsoft Kinect and the Nintendo Wii have also revolutionized the gaming industry, and we're seeing other technologies recast the way in which we interact with computers and other devices. Finally, major progress in the healthcare industry has allowed us to make extensive use of medical imaging data to provide us better diagnosis, treatment, and prediction of diseases. And these are just a few of the applications, but there are many other subdisciplines which are beginning to use computer vision to solve different problems. So let's begin by talking about the structure of data.